up! What is all this? Edwin Hubble, the discoverer of the expanding universe? And the Big Bang? Think again. I know, that's what we've been taught for the past 80 years or so, at school and even at university. But that truth is now being reassessed as, well, not so true. In this video, your member of the public will explain why and how. Edwin Hubble, America's born and bred answer to Einstein. After centuries of major scientific discoveries hailing almost exclusively from Europe, finally here was a man who showed that America could stand its ground against the persistent arrogance of European intellectual dominance. A man fit for a stamp. He even has a $10 billion space telescope named after him. Born into a well-to-do Midwest family, with dad being an insurance executive, he's given more educational opportunity than you can shake a stick at. Yet, rather remarkably, young Hubble is apparently more attracted to the less cognitive perks of a privileged education. At school and university, he excels in baseball, football, and running track. In one single high school track and field meeting in 1906, he wins 7 first places and a 3rd place. In basketball, Hubble even leads the University of Chicago's team to their first conference title in 1907. And as if that is not enough, he also boxes in the Gold Gloves competition, at one point even knocking out the German heavyweight champion. This sports jock clearly is a man who is competitive, ambitious, and ruthless. Qualities, though, we don't usually associate with scientists. I know, we shouldn't be talking in stereotypes. But scientists tend to be perhaps a bit more bookish, exercising their brains instead of their bodies. The profile of Hubble better corresponds to that of a hands-on guy, like a manager, or perhaps a lawyer. And that's indeed what he studies, first in Chicago and then in Oxford. Not physics or mathematics, but law. Some will put it down to a dominant father, who forced him into studying law. But hey, here he is at 24, and still plenty of time to do a 180 and make one of history's most important scientific discoveries. Once graduated as a lawyer, his legal career starts off a bit on a wrong foot. So he ends up teaching Spanish and some math at a high school, which allows him to indulge once more in his favorite pastime, basketball, this time as a coach. This is all nice and dandy, but rather puzzlingly, still no sign at 25 that we're dealing with someone who's going to produce the exquisite science that will forever change our view on the universe. And then suddenly, through the intervention of a roommate turned professor, our jack of all trades is allowed to get a PhD in astronomy, another one of his juvenile passions, inspired by granddad's hobby. The science of astronomy in those days still very much consists of the physical act of looking through an eyepiece and taking notes. So all you need to do is make some pictures of nebulae with a campus telescope, write up an accompanying rather descriptive paper, and you've earned your astronomy PhD. Just in time for the US entry in World War I. For Hubble, this is merely an opportunity to shine again, as a sportsman. So he volunteers, and as a PhD, he quickly rises to the rank of Major. Disappointingly, his division never sees any action, but hey, he got to wear this dazzling uniform. Unfortunately, the war is already finished after 1 year. He decides to stick around for another year as an astronomy student in Cambridge. Who wouldn't? By that time, he has already turned 30 and has worryingly little in the way of scientific achievements to show for it. And then, almost exemplifying of how important networks are in one's life, he gets an invitation from another old pal from his Chicago days, if he would come and join him at the staff of Mount Wilson Observatory in sunny California. Some people do have all the luck. The year is 1919. Crucially, and we cannot stress that word enough, crucially, this observatory holds the largest telescope in the world, the Hooker telescope. At 100 inch, the lens is almost half larger than that of the next largest telescope, which is a mid-19th century relic rotting away at the grounds of some damp Irish estate. In addition, the quality of the Hooker lens is innumerably higher. Those size and quality leaps combine into an unprecedented, bafflingly detailed view of the skies. The Hooker only just came online and is merely waiting for someone with some formal education in astronomy to put it through its paces. Rewind to 1912, to the little country of Belgium, to the provincial town of Charleroi. A devout young man of humble beginnings, by the name of Hubble-Lemaitre, 5 years Hubble's junior, displays exceptional mathematical talent at the local Jesuit school. At the age of 17, he is allowed to enter the civil engineering program at the prestigious Louvain University. When World War I breaks out, he is sent to the trenches as an artillery officer. But as an aspiring priest, this is not really his cup of tea. Still, he ends up being decorated for bravery. Despite losing 4 years in the war, in 1920 he receives his PhD in mathematics and physics, and in 1923 he is ordained a priest. In 1905 and 1915, Einstein has published his relativity theory, but it is still understood by only a handful of people. Lemaitre writes a paper on the subject, and an international jury is so impressed that he obtains a position as a research fellow at St. Edmund's College in Cambridge, to physics and mathematics professor Arthur Eddington. Back to Hubble. For a while now, he's been playing around with the world's most expensive scientific tool, frantically looking to turn his chance appointment into success. Then he decides to do something different than looking at boring planets. He points the telescope at what is at that time still called the Andromeda Nebula. The magic eye of Hooker allows him to discover that it is not a nebula at all, but rather a cluster of stars. So in 1923, to worldwide acclaim, Hubble announces that what people before thought to be nebulae in the Milky Way are in fact galaxies in their own right. To determine their distance and speed, he simply uses well-established methods, such as redshifting, developed by, among others, Vesto Slipher. These methods were previously unpractical for these kinds of huge distances, but now, courtesy of the enormous and unique power of the Hooker telescope, and some tweaking by Hubble, can extend their reach beyond our galaxy. Hubble conveniently ignores the contributions of the Hooker in his triumphant press releases. And the American press, and by extension the world press, is only happy to oblige. A science legend is born. In the meantime, in Cambridge, Lemaitre continues to impress his peers, and is soon sent to work at the Harvard College Observatory in Massachusetts. In 1926, he earns a science PhD at the renowned Massachusetts Institute of Technology. He then returns to Belgium. He has now also reached the age of 30. Lemaitre can't get his mind off relativity theory. In 1917, Einstein had added the concept of the cosmological constant to his field equations, in order to make their solution conform to the then common notion of a static universe. This keeps bugging Lemaitre, and he decides to try and extend the field equations, with the hope of finding a solution that doesn't require the cosmological constant. So early 1927, he publishes his newfound theory in an article called Un univers homogène de masse constante et de rayons croissants, rendant compte de la vitesse radiale des nébuleuses extragalactiques. Lemaitre takes Einstein's field equations and constructs his own intricate mathematics on top of them. All the while he references as much as possible to findings known to him to have already been published by his peers, as prescribed by scientific etiquette. His mathematical development eventually leads to this weird conclusion. It appears that space is expanding, and this at a relative speed to the observer that is proportional to the distance to that observer. In other words, if you divide that relative speed by that distance, you should always get the same constant value. This will, tragically, later become known as Hubble's law. To get an idea of the value of that constant, Lemaitre takes the publicly available raw data on velocities and distances of galaxies, as observed by Stromberg and Hubble at the Mount Wilson Observatory, and enters them in his equation. For the first time in history, the value of what later, again tragically, will become known as the Hubble constant is calculated, be it in a very approximative way, due to the limited scope of the data used. Then later in the same year, Lemaitre is invited to attend the 5th Solvay Congress of Physics in Brussels. This congress gathers the most beautiful minds in science alive, including Schrödinger, Pauli, Heisenberg, Bohr, Planck, Lorentz, and of course Einstein. It is there that Lemaitre and Einstein meet for the first time, and to Lemaitre's astonishment, Einstein has already read Lemaitre's article. He comments, "Your mathematics are beautiful, but your physics are terrible." Einstein, who still believes in the static universe of Newton and Spinoza, simply can't emotionally and culturally bring himself to accept Lemaitre's conclusion. A few years later, however, in 1931, he eventually will admit defeat. Then, much to Lemaitre's surprise, Einstein points out that in 1924, in a German publication, a Russian physicist by the name of Alexander Friedmann also mathematically concluded on an expanding universe. But he didn't derive the existence of the Hubble constant, or for that matter, Hubble's law. In 1928, Lemaitre visits a conference of the International Astronomical Union, the IAU, in Leiden, in the Netherlands. Another visitor has also arrived, after a tiring boat trip. It's Edwin Hubble. According to the IAU itself, here our two antagonists finally meet. We will never know what exactly was said or exchanged during this meeting, but we do know that Lemaitre used Hubble, or should we say Hooker, as a data source in his article. So it is almost inconceivable that Lemaitre didn't talk to Hubble about the conclusions of his article. Hubble was never really mathematically gifted, much more an observer and a statistician. But the beauty of Lemaitre's mathematics is that they are complex, but have a very simple conclusion. The ratio of speed to distance is constant. So a 15-minute coffee break between two presentations during that conference would have easily been enough to get the message across. Lemaitre would have done this without giving it a second thought. Remember, he's a vocational Catholic priest. His instinct is to help other people. And this is where the drama starts. 1 year later, in 1929, Hubble publishes a relation between distance and radial velocity among extragalactic nebulae. The article is only 6 pages long and suspiciously lacking in references and mathematical development. There's a lot of descriptive text and some observational tables about galaxy velocities and distances. But then, out of the blue, there's a graph that sets out those velocities and distances against each other. The correlation is obvious. Hubble simply calculates its coefficient and calls it k. It is then that the Hubble constant gets the name by which, to this day, it is known. Again, the Hubble public relations machine kicks into gear. Hubble is now touted as a true master of the universe. He will later even try and get astronomy recognized as a Nobel Prize discipline. Guess who he imagined to be the first recipient? Oh dear. I wonder why Hubble keeps reminding me of that other American superhero with just as unselfish and noble goals in life. Is it the pipe? Amazingly, it is only in the last few years that the debate has emerged as to whether Hubble, prior to announcing his discovery, was aware of Lemaitre's article, or at least the conclusion to that article. If he was, that would make him a cunning intellectual thief, coldly calculating that Lemaitre, an unassuming do-gooder Catholic priest, tucked away in some quaint little country with funny languages, wouldn't object to Hubble taking the credit. If he wasn't, in other words, if he independently from Lemaitre's article, through mere observation, discovered Hubble's law, would that grant him any naming rights? To answer that question, let's have a look at the process of scientific discovery. The standard procedure for discovering physics laws is that you first carry out a number of experiments or make a number of observations in the field in a direction you expect to find something interesting. Then you try to identify patterns or correlations in the data you've observed. If you find some, you try to design a mathematical formula or model that is able to predict these data. If you succeed, congratulations! You have the immeasurable honor of having a physics law named after you. No need to worry about understanding why it is that your formula or model predicts reality. That is up to future scientists, when science has gained new insights. But the law will forever be named after you. But sometimes this standard discovery procedure does not apply. That is the case for laws pertaining to relativity. They can be discovered entirely theoretically, through mathematics. Einstein didn't need any observations to arrive at his field equations, nor did Friedman to arrive at the Friedman equations, and nor did Lemaitre to arrive at the so-called Hubble constant in 1927. These theoretical discoveries, per definition, also explain why that particular formula or model applies. So the discovery process has right away reached its pinnacle. It is true that theoretical laws afterwards need to be confirmed through observations, actually applying the reverse of the standard procedure. But these observations no longer carry the prestige of discovery. They are merely a scientific formality. A good example is that of Arthur Eddington, Lemaitre's mentor in Cambridge. To confirm Einstein's relativity theory, in 1919 Eddington organized a perilous expedition to the far-flung island of Principe, off the west coast of Africa, where a solar eclipse was due. The eclipse allowed him to observe that the light of stars hidden by the sun was indeed being bent by the sun's gravity, as predicted by relativity theory. Eddington had confirmed Einstein's law. Theoretical laws are usually too complex to be discovered through the standard discovery procedure. But Hubble's law is an exception. It consists of a simpler ratio. So, with a serious bit of luck, it could have been discovered observationally prior to Lemaitre's article of 1927. However, you would have needed access to the world's largest telescope, the Hubble. And since that only became operational a decade earlier, there wouldn't have been much time to spare. But if you had pulled it off, Hubble's law would have been rightfully named after you, despite it being a theoretical law. As we all know, Hubble didn't make it. He published his article in 1929, a full 2 years after Hubble's law was discovered and published by Lemaitre. So too bad. No naming rights. Yes, I know what you're thinking. Aren't we being a bit too harsh on the man? After all, he presumably did discover independently from Lemaitre. So can't we retain the name somehow, like in Lemaitre-Hubble law? Well, no. Even if Hubble discovered independently, it's never going to be a tale of two equivalent discoveries. You see, Lemaitre discovered theoretically, and with theoretical discoveries, the observational part, it's a bit like playing among the reserves in football, to stay in sports. It's not supposed to carry much weight. Remember Eddington? I bet before this video the majority of you never even had heard of the guy. And he's the one who confirmed relativity theory. And the fact that Hubble presumably made his confirmation observation independently, that changes little. Besides, you would only be applauding Hubble's ignorance of the state of the art of his discipline. Because of course, the fact that Lemaitre's article was published only in French doesn't exempt any scientist who doesn't speak French from its anteriority. If it did, then what about Einstein's articles on relativity? They were all published in German. And then there's the legal concept of the burden of proof resting with the one who makes the claim. If you claim to have made an independent discovery, despite that discovery already having been published 2 years earlier by another scientist, then it is not up to that other scientist, or for that matter, the scientific community, to prove that you were aware of that article. No, then it's up to you, the one who makes the claim, to prove that you were unaware of that article, which is in itself not so flattering. Hubble as a lawyer must have been familiar with this concept. Sadly, he never gave such proof. A well-documented article with a detailed description of how he developed, preferably mathematically, the idea of comparing speeds to distances would have been a good start. Unfortunately, this is not what that article looks like. Surprisingly, when the unraveling truth grew too embarrassing and the IAU in October 2018 put a name change of Hubble's law to its members, it didn't give Lemaitre law or Lemaitre-Hubble law as the alternative, but Hubble-Lemaitre law. Yearning for a desperately needed name change, the IAU members voted 78% in favor. Now, the IAU is a time-honored, respectable international institution, so it's only normal it wishes to behave diplomatically towards its members, of which a substantial number are American. Fortunately, your member of the public is untrammeled by such constraints. So let's have a look again at that diagram. Once it's drawn, any science graduate can calculate that correlation, and therefore the Hubble constant, and therefore Hubble's law. The question is, how come Hubble had the idea of drawing it in the first place? You can calculate literally thousands of ratios between all manner of astronomical data and put them in as many diagrams. But each time you do that, it costs an enormous amount of time and resources. So, if you pick one, you do that because you have a reasonable hunch of discovering something. So that raises the question, why would Hubble have had that hunch? That there would be a constant relationship between speed and distance, no matter in what direction you appear into the universe, no matter where you observe from. It's entirely counterintuitive. Unless, of course, you thoroughly understand relativity theory. Not only that, you also have to mathematically develop yourself the extended equations of Friedmann and Lemaitre on the expanding universe, and then the equations that are unique to Lemaitre, which derive the existence of the Hubble constant. As it so happens, there is no proof that Hubble ever read, much less understood, relativity theory. There's often a misconception about this expanding universe. It's not that objects like stars or galaxies are simply speeding away from each other. The distance increases because space itself is being stretched. Not only between those objects, but also within them, including within ourselves. Only there the increase is so small that it is irrelevant to day-to-day life. It becomes noticeable, though, over the huge distances and speeds that exist in the universe. But there's no way you can deduct such an outrageous idea from merely looking through the eyepiece of a telescope, even if you succeed in determining the distance and speed of those galaxies. You need the mathematics we discussed earlier to set you off in the right direction. So, if Hubble somehow did develop these mathematics, where are they? Without them, the chances you decide to investigate the Hubble ratio are nearly non-existing. Unless, of course, someone else, like for instance a Catholic priest during a coffee break at a conference in Holland, tells you what to look for. Then you merely have to press a few buttons and turn a few knobs on your magnificent telescope, and voila! If there is still any doubt as to how alien the whole idea of an expanding universe was to Hubble, in 1941 he inadvertently removes that doubt himself. In a Los Angeles Times article, he categorically states that after 6 years of searching, he still hasn't found any evidence of what he disparagingly calls an exploding universe. So we have the utterly bizarre and surreal situation of a man who discovered the ultimate proof that the universe is expanding, in other words, Hubble's law, and then till his dying day will refute that the universe is expanding. So, in Hubble's best case, all we can credit him with is that he confirmed Hubble's law, just like Eddington confirmed the relativity theory. But as said, this is not supposed to grant you any naming rights, even if your confirmation was done independently. However, circumstantial evidence, another term Hubble as a lawyer would have certainly understood, points to a disturbing truth, in which that purported and perceived independence was but a carefully crafted media ruse, designed to turn windfall information into a road to scientific immortality. So we can, with a high degree of confidence, conclude that Edwin Hubble was the lawyer who robbed the priest, in what is arguably the biggest intellectual heist of the 20th century. So it has to be Lemaitre law, and Lemaitre constant, and Lemaitre volume, Lemaitre time, Lemaitre length, Lemaitre parameter, Lemaitre whatever. That is, of course, if the international scientific community has a tiny bit more moral courage than it already displayed. And don't worry, the IAU will be happy to drop that dreadful accent circumflex. I'm sure Father Lemaitre himself wouldn't have minded. In fact, Father Lemaitre never even minded seeing during his lifetime his discovery being named after Edwin Hubble. But then again, he was a priest, not a lawyer.
Lemaitre didn't stop there. In 1931, he published L'hypothèse de l'atome primitif, which suggests that an expanding universe implies that if you go back in time, it should get smaller, until at some finite time in the past, all the mass of the universe is concentrated into a single point. Lemaitre calls this the primeval atom, where and when the fabric of time and space came into existence. In 1933, Lemaitre gave a lecture on the subject at the California Institute of Technology. Einstein was once more in attendance. He is reported to have said, "This is the most beautiful and satisfactory explanation of creation to which I've ever listened." Though it's only a couple of miles from Mount Wilson to Pasadena, Edwin Hubble was nowhere to be seen. Lemaitre's primeval atom theory would later become known as the Big Bang theory. In 1949, a British astronomer, Fred Hoyle, coined the term in a BBC radio broadcast. Actually, very much like Hubble in 1941, he was making light of Lemaitre's mind-boggling insights. But the term stuck. Hoyle's name, not so much.
So there you have it. Do with it as you see fit. But allow your member of the public to sign off in a slightly different manner than we started today. See you next time.
Thank you.